Here we are back at the test stand. Got a socket that I've cut. You can just see the slot I've cut in the socket there, and that goes onto the end of the distributor. So we've got our usual, there we go. Now you can see there it's flashing right on the window. And if I just increase that, there you go, you see it jump there. Now that is 2400 revs on the tacho. Now 2400 revs on here is 600 engine revs, because we're getting 6 pulses per rotation to the distributor instead of 1, which would be on a single spark plug. So we'll just take that up. Now the tacho only goes up to 9,990 revs, which is equivalent of around about 1800. So you can see the advance there. And if I back it off, you can see it come down. There's the sort of running speed. That is showing on the tacho 6,000, which is 1,000 engine revs. Now we're back down to about 4,100, which is what, 660 revs. So if I take it down to 600 revs, which will be 3,600 on the tacho, which is what it is right now, you can see there that we've got a little bit of advance from what our cranking speed was. Now what I've done, I've measured it there, sorry, with this one, and that shows around about 2 millimeters of advance. Now if you take a radius on here of 33 millimeters and a chord of 2 millimeters, that gives an engine variation of 7 degrees. So it looks like when we're cranking, we retarded 7 degrees. And that sort of makes sense, because you don't want, at very slow engine speed, the mixture to be firing early, because it's going to try and stop the piston coming up. So that actually really makes a lot of sense. So there's our normal speed. Then you can see it just jump there to idle. I suspect my drill's not very even, not very smooth speed-wise, which is why it's a bit jumpy. And you can see it there, and then you can see the normal advance curve kick in. There's our running speed of sort of around 800 revs, and then back to cranking, effectively cranking there. Okay, that's the end of that. I'll upload to YouTube for you.